Okay. My name is Brad Wilson. This is me when I think really hard. I want to thank you guys all for coming out. I mean, nobody would have guessed that we would have a sunny day in May. So, thanks for choosing us instead of the patio with beer, which will be there an hour from now. So, appreciate that. I've been doing software development for a couple of decades now. I've worked at Microsoft before I worked here. I worked at the ASP on that team for about 5 years. Worked on ASP at MVC and Web API. My history has been mostly enterprise application development. So I'm going to talk a little bit about this project that we have called ElasticLINQ, which is basically combining the power of LINQ. I assume some of you have used LINQ or MD framework? Yes? Pretty much everybody. How many of you have used a NoSQL database? Less. Okay. By the way, I have not uploaded these yet, but on this bit.ly link, which I'll give you again at the end, I'll put the slides. And I also have the code for all of this on my GitHub. Okay. So, let's talk a little bit about SQL versus NoSQL. There's a lot of directions we can talk about the differences. This is kind of like the key points that I really want to talk about. In particular, what I'm going to talk about today is NoSQL document stores. There's a few varieties of NoSQL databases out there. There's table stores like Cassandra. There's document stores like Couchbase and Elasticsearch. There's also key value stores out there as well. We found for us the document stores were sort of the most useful transition. And we'll talk a little bit about what some of these differences are. So when you think about SQL, you think about tables, right? You think about tables and relationships. Those tables are very flat, right? They don't contain any depth to them. So how do we get that depth? We usually get that depth through the relationships in other tables. So, one-to-many and many relationships, and bring those in by many tables, and sometimes tables in between that really are just about drawing those relationships together. In NoSQL document store, instead we start thinking about documents. And when I say document, what I really mean is an object, JSON. So for those of you who've done web development, this is really, arbitrarily deep and structured data. So you don't have to think about tables and relationships in that sense. You think about storing your objects as you already have them inside your database. So this notion of how you map these things together actually becomes a lot simpler than in traditional systems like LINQ to SQL or Entity Framework, where it has to sort of deduce the relationships via the table. A lot of those relationships will be contained directly in your document. So you load the document and everything will be there. The second thing I want to talk about is centralization. Typically when you run a SQL server, you're going to run one, or maybe a small cluster of them. But you generally are going to run one server, and the way you're going to scale it up is you're going to make that server bigger. That is good until you run out of the ceiling. Once you run out of the ceiling, then you start having to come up with crazy schemes for how to rip the data apart, and how am I going to put some of the data over here, and how am I going to put some of the data over here, and what am I going to do when some of the data needs to live on the East Coast and some of it needs to live on the West Coast? What am I going to do when all of it needs to live on the East Coast and the West? These are problems that tend to be very difficult with current SQL products. So one of the things that you'll see very commonly in these document stores is that they are decentralized, they're distributed. Right? So they make it really easy for you to take a document and put it in one place and have it show up in many other places. So the way you would scale this, you can obviously scale up. Scaling up is fine. But once you've hit a ceiling of scaling up, you can also scale out. And sometimes scaling out is better anyway. Especially if you start thinking about running these things in the cloud, scaling out tends to be something where you can just turn machines on and off as needed. Right? You can look at the traffic and say, I'm having a traffic burst. Turn on 2 or 3 machines and they magically join into the cluster of machines and the data starts redistributing itself. Okay, so scale out tends to be much easier with these NoSQL databases. A strong point useful with SQL is it's a known quantity, right? People don't get fired for recommending you use SQL Server or Oracle. Most people have never used a NoSQL document store. For most people, it's going to be a learning curve. And so it has to be, let's say, an environment of trust where you're allowed to make that decision. And so hopefully I'm going to be able to give you enough information to help you make a decision about, when and where you want to use these things. And then the final thing, and this is one of those things that it's either good or bad depending on your company. SQL databases tend to usually be expensive commercial products. There are exceptions, right? Two really well-known exceptions are Postgres and MySQL. Although I would argue whether you should ever put data in MySQL. The opposite side is NoSQL data stores tend to be open source. They also tend to usually have a company behind them, and the company's primary way of making money is usually support. Right? So think about the Red Hat model. Take Linux. Linux is open source. We put some extra cool stuff in here, charge you money for support. That tends to be the model here. So, considerations for when you're moving your data into a document store. One thing to think about when you're structuring your documents is that they are typically your data domains. Has anybody done domain-driven design? Ever heard of it? Okay, only a few. The notion behind domain-driven design and data domains is that you generally have these sort of top-level things that tend to be the things that you're interested in querying about. And especially in SQL, you'll have these other things which are really sort of support. So think about an order, right? An order is a domain item. A line item on an order, despite the fact that it might be in a different SQL table and hooked up via relationship, not really a domain item. You don't generally go looking for a line order. You generally go looking for orders. Right, so in that sense, the documents you're going to put in your NoSQL database tend to be these top-level things that you're interested in querying on as sort of the first order of your query. Okay? They typically are the concurrency granularity in document stores. This generally means this is the thing you update all at once. And if you have any concurrency support in your database, that generally means that's sort of the level of it. Right? So there's not cell locking, row locking, table locking, database locking. There's really just sort of document locking. Relationships, when you need to draw relationships between domain objects, tend to cost you an extra round trip. Whereas in SQL, you would just do a join on the SQL server and have it all brought down for you. You have to be a little conscious of where you draw those lines to say, like let's say I was going to put orders and order lines as separate documents. I'm pretty much always going to put order lines when I put orders. Right? That's a hint to me that I want to put those things together. Let's see. Ad hoc reporting. So a lot of people use SQL Server for reporting. One of the reasons it's really good at reporting, aside from the fact that it's got an entire separate thing for reporting, which is data cubes, it tends to be very good with numerical data. So ad hoc reporting can be challenging in document stores, depending on the functionality that's built in as to whether or not it's easy for you to get statistics and things like that. So we'll see that some document stores offer MapReduce. So MapReduce is this notion that every time I see a document come into the system, a new document or a change document, I can look at that and I can emit more documents into a different table as a result. Right? So if you think about this, this is like views in SQL. A view where you'd write a relationship together and say, I just want this thing to look like a table. MapReduce in these document stores generally serves that same purpose, to give you a view on your data. A lot of the document stores you can use third-party data aggregation reporting with. One of the things I'll show you is a tool called Kibana. And Kibana is a data reporting system that's built on top of Elasticsearch. And then finally, don't dismiss the notion that you could take the data and replicate it. Right. So data that needs to be counted and reported on, you can always just put in SQL Server, right? You don't have to always just pick one or the other. Okay. So why Elasticsearch? we went down this path and we evaluated a lot of document stores. And that's Elasticsearch wasn't the thing we chose first. The thing we chose first was Couchbase, which I'm going to talk about in a little bit. But what ended up happening is Couchbase's preferred search mechanism right now is Elasticsearch. So that's how we ended up getting into Elasticsearch. Turns out that was actually a really good thing because Elasticsearch is this really powerful thing. Built on top of the Lucene engine. Lucene is probably a premier indexing engine out there. It's written by Apache. So it's built on top of this. But what they added on top of it is they added on top of it the ability to do this sort of low-friction sharding and replication. So whereas a Lucene index would be sitting all by itself, they've built up the ability to distribute that information as well as to distribute the ability to query that information. So one of the nice things about Elasticsearch is it has a simple HTTP web API. So you want to put a document in it, you send a put an endpoint. You want to get a document, you use a get endpoint, you'll get that document back. Even the search API is done that way. JSON is a first-class citizen, so when we talk about documents in Elasticsearch, we are talking about JSON. Okay? Lots of great documentation. This can't be emphasized enough. Most open source projects have terrible documentation. So it is good to find one that has good documentation. And of course, this is because there is a company behind this, right? And they have available support contracts. So if you go to elasticsearch.org, you're looking at the open source organization for Elasticsearch. If you go to elasticsearch.com, you're looking at the commercial company that wants to sell you support contracts. Okay. One more thing, and then we'll start the demo. This is the execution pipeline for Elasticsearch. And we're going to talk about what each of these things is, but essentially a query is the first thing that gets executed in the pipeline. And a query is generally a very powerful search. So powerful that you can get scores on the results. So if you ever, you go to Google and you do a Google search and they give you ranked results, well, that's scoring that's really ranking those results for you. So queries in Elasticsearch are like that. Right? They score the results and say, this is probably the most important thing for you. The next thing you can do is you can filter. A lot of things you can do in a query, you can also do in a filter. The difference is it doesn't score. So why do they have two steps? Queries are expensive, filters are cheap. So you have to think about the kind of search you're doing. Is this the kind of search where I care about scores or I care about relevance? Or is this the kind of search where I expect to just find one or two things and just pull them back? Okay? So most of what we do is with filters. But when a user comes to our site and they type something in the search box, that's a query. Because we want to score those results and give them the best results back. So we use this not only for searching, we use think of in a SQL full text index kind of a way. We also use it for retrieving the documents that describe all the parts of our system. Virtual machines, users, accounts, activity history, you name it. We have documents in Elasticsearch for it. Okay, let's do a quick demo of Elasticsearch. Okay, oops, that is not the browser I want. That was the browser I want. Okay. Elasticsearch, let's open a command prompt. I told you Elasticsearch has an HTTP endpoint. Okay, so let's see what happens if I hit that HTTP endpoint. I get back a document which describes the state of the server. Okay, I'm in good shape. This is my name. This is the version of the software I'm in. I can look for a particular document. Let's look for employee number 1 in Northwind. That's not particularly readable, but that is the JSON document of the employee. Let's go ahead and do this. Let's do this. So make it a little bit more readable. This is a PowerShell command-line called invoke rest method. And you can see what comes back here as he tries to describe it in an object form is information about this document. What index did it come from? What type is it? What is its identifier? What version is it? So how many times have I written this? Is it actually there? It seems like a crazy thing, but yeah. Is it actually there? And then source, which is the actual document itself. So let's go ahead and look at source. Okay, so there's the document itself. If you already use Northwind, that's the mention of Olio. She is employee number 1 in the Northwind Corporation. Okay, so this is the simple REST API that you can use. Most people will not use this with a command line. I just wanted to demonstrate, what this API looks like. There's also a search endpoint, and posting the search endpoint requires constructing a JSON document which describes the thing that you want to search. That's kind of a pain to do from here. So that guy in the brown shirt over there wrote this tool, which is called QueryMe, and QueryMe is a tool that lets you run queries against Elasticsearch. So we'll come back to this in a minute, but it allows me to basically type in the JSON of the search that I'm interested in and then get the results back. And the first thing I want to show you instead, though, is this other plugin is called Head. And Elasticsearch doesn't contain a management UI of its own. It really literally is that HTTP endpoint, and that's it. But it does have a plugin system where it can host static HTML for you. And so the static HTML, believe it or not, there's no server code running here other than he brings this HTML down with some JavaScript, and this JavaScript posts up to that endpoint. I could change this IP address to point in an entirely different server that wasn't running Head, and I would be able to administer that server and find out information about that server, because it does it all through that HTTP endpoint. So everything in Elasticsearch, the management of documents and management of setting of servers is all done through that HTTP endpoint. We like Head because Head has a nice graphical display about what's going on with the server. So let me go ahead and I'll do a quick refresh on this guy. And you can see I have actually 2 servers in my cluster here. They have 2 indexes, one called Beer Sample, one called Northwind. I'm going to go ahead and I'm going to go into one of my boxes. And I am going to stop Elasticsearch. And you can see what happened here in the background is that box disappeared. Right? Elastic02 has disappeared. And now we have these unassigned documents. Well, what are these unassigned documents? The reality is when you make an index, so you can think of an index as like a table, okay? Or, it's a container for documents. When you make an index, aside from giving it a name, you can tell it how many shards and replicas you want. So, how many of you have done sharding with SQL Server? Hardly anybody. Okay. So sharding is the notion that you're going to split your data up into pieces, right? And I'm going to say, this piece lives over here, this piece lives over here, this piece lives over here, right? So sharding is basically just a built-in thing inside of Elasticsearch. And what it basically says is, I want you to split the data up in 5 ways. And he automatically figures out how to split it up for you. There's no complicated logic on your end that's necessary. He just sort of figures out where all the documents are. And then replicas is how many additional copies would I like? So let's say I make a test index and I say, I don't really want any extra copies, but I'll go ahead and I'll make 4 shards. Okay? So I'll make this test index. And now what we've got here is, we have this test index over here that has these 4 copies, and it doesn't have any that are unassigned. So what these unassigned ones are telling you is, you told me you wanted an extra copy, and there's nobody sitting out here who's willing to take an extra copy. So this is why he's telling me, oh my God, you're yellow, right? You should be careful, you're about to lose data. So if I go ahead and bring that server back up, I want to start the refresh because I want to see how quickly this happens. I go ahead and I start him. I can start him. There we go. So Elastic02 shows up here in the list, and Elastic01, this star, he's saying, hey, I'm the boss. And what he's doing now is he's saying, well, I need to distribute the data around, so here I've distributed the data around. In the 2 where I wanted replicas, he made sure to give him a copy of everything, because now everybody has a copy. In this one where I didn't need replicas, he cut all the data in half. He's like, you run this half, I'll run this half. Okay? By doing that, he's sort of spread the load around on all the servers to say, you can answer the questions for these, and I'll answer the questions for these. Okay? So what's bad about this is if I was to take that box down right now, like if he was to disappear without gracefully shutting down, those documents would not be available. Right? So the idea of scaling out is that you sort of make a decision about how many documents you want to have sitting in which place. Anybody have any questions on that? No? Okay. Well, let's go ahead and delete this guy. So, one of the things I did is I got the Northwind data set, which is a data set Microsoft shipped in 2000 now, 14 years ago. Available as SQL tables. A friend of mine had adapted this for an object database that he worked on called RavenDB, and so I borrowed his copy and put it into Elasticsearch, and then I would have a data set that some of you have probably seen before, so we can start talking about how this is all put together. So let's go over to query me. The query me right now is querying the Northwind index, and he's querying the product data type, document type. Okay? So everything in Elasticsearch, all the documents have to have a document type. And you can sort of think of this as the delineation between how do I describe this document versus this document. So in the case of Northwind, I think that there's 8 or 9 different document types. And those were sort of the domain, the top level domains as Andy had seen them when he pulled them apart and put them in RavenDB. So I went ahead and copied that over here. So let's do some queries against the product database. You can see if I pass an empty JSON object, what he's actually done when I run this query. The first thing is he's telling me it took 88 milliseconds to get the data, and that there were 77 products documents in Elasticsearch. And he's showing me the first 10. And you can see that there's a lot of metadata sort of describing what's going on here. How long did it take? Was there a timeout? Was I able to talk to all the shards and give you data, so you can sort of figure out whether you're looking at partial data or not? How many total documents match? What's the maximum score? And then you start listing all the documents. First thing you notice is 110 documents out of 77. So that's Elasticsearch's default is to give you the top 10 documents. You have to remember, this is primarily an indexing engine. So if you think about searching, 10 results is probably entirely reasonable. You can obviously influence that, and we'll talk about that in a little bit. But let's start talking about some of the queries that you can do. So let me grab my super cheat sheet over here. Okay. So the first thing I'm going to do is I'm going to set up a filter. So remember I said filters are the things that don't have scores, but they're very fast. And what I'm going to do is I'm going to filter things that have chef in their names. So I'm going to take all 77 documents and figure out which ones have chef in their name. So now we've got 2 of 2 results. So the Chef Anton Stage and Tuesday and Chef Anton Supplement. So what really happened here that you didn't see is there's a hidden query going on, which is basically, give me all the documents. Right? Because remember, it's in a pipeline. So the first query is, give me all the documents and store them. Well, didn't ask for any, so I'm going to give them all to you. What's the next thing I'm going to do? I'm going to run a filter on them. And the filter is, show me the things that have the name Chef. Have Chef in their name. Okay? And then there are other things, the Facets stuff and the paging stuff, which we haven't talked about yet, but we'll get to in just a moment. Okay, so that is a fairly simple query. Anybody have any questions on that? Yes. The question is the filter happening on the client or the server side? It happens in the server. So you send this query up to Elasticsearch, and it runs its pipeline, which includes the filter, and gives you back these documents. I'm going to check this box which hides a bunch of stuff so that we can just look at it, the results from now on. Okay. So one thing that's interesting to notice is because, yes, you have another question. Actually, I'm going to talk just about that. What's interesting is that, let's say I search for CHE. What I'm going to find is no document. And the reason is, remember that what's underlying this technology is indexing. Right? So what it does is, the filter that we have installed when we put documents in there, splits things on white space boundaries. Okay? And so, why I didn't find CHE is there was no names that had CHE as a word. Whereas chef is a complete word. So if I was to put Anton here, you'll see that I won't get any hits because Anton had an apostrophe in it. It's not until I say Anton, apostrophe, that I get my documents back. Okay? Something else to think about, because this is an indexing engine, the other thing that we have this thing doing is we have it converting everything to lowercase when it goes into the index. So if I was to search for this with a capital A n times, I won't get it back. Okay? And there's a lot of ways you can configure Elasticsearch. This is the way I happen to have it configured for me, which is break things on white space and lowercase everything. One of the nice things about lowercasing everything is it's much faster for him to find, but the downside is I have to give him lowercase queries. If I want to find n times with a capital A, I need to turn it to a lower A before I send it to him, so I know he's going to find it. Okay, so this is one of the nice things about this is ElasticLINQ does this for us. So, what does the equivalent look like in ElasticLINQ? Alright, let's talk a little bit about ElasticLINQ. So, you've all used, well, pretty much everybody raised their hand, you've all used LINQ at one point or another. This is going to use the exact same LINQ that you're used to using. The difference is, instead of talking to SQL Server, he's going to talk to Elasticsearch. So I have a context here, there's the Northwind context, he's talking to that same server. And what I'm going to do is I'm going to say context.query, and query takes the key. So I'm searching for a product, right? So I already have a product class that looks like that JSON object. So a name, a supplier, a category, a quantity per unit. If I go over here and I look, you can see name, supplier, category, quantity per unit. Right? I have this class, which, by the way, I'm going to show you a really cool feature most people don't know exists. I'm going to go grab this guy, right? This is our definition of what a product looks like. So how did I get this class? I didn't write this class by hand. I used a feature inside Visual Studio with AutoWA which is what I know about it, which is called edit, paste special, paste JSON as classes. How many knew this existed? Except for the people who put it in there. Alright, so let's see what it does. I paste JSON as classes, and he gives me this JSON object. Right? He doesn't know what to call it, because the top doesn't really have a description, right? This is really a product. And he just took that and gave it to me. And he looked at the data and he said, these look like strings and ints and bools. And he automatically converted it. So this is a very convenient thing. I use this all the time. Very cool. Alright, so the product object that I already have has one of these in it, right? So I have a query for product. And now the result of this, I'm going to minimize this guy. Now the result of this is that I end up with a queryable, an iQueryable of product, right? It's exactly what you'd expect out of LINQ to SQL or Elastic or any framework. It's going to give you an iQueryable of this thing so you can now write code against it. Okay? So I can say from product in that guy. Well, I might not have a quarter instead of well, I like writing it the other way. So, I'm going to say, give me all the products where the name is chef. Okay, so that is my query. So if I was to take that and say, queries for products, and queries, products.name, and then run this guy, we will see our two things. Okay? Check on time Dumbo season, or Dumbo makes sense agency. And what's even cooler about that is, let's take this query now. Let's ask this query, what would it have sent to Elasticsearch? We've added this extension method, which is called Elasticsearch query. And he's actually going to give me the JSON that he sends up to Elasticsearch and defines this thing. So this looks exactly like the one that we sent, except for this timeout. Alright, so ElasticLINQ tells Elasticsearch, you can't give me an answer in 10 seconds, don't bother. Yeah, that's one of the things that's configurable, but you can see this query looks exactly like the one I would have written by hand to go talk to Elasticsearch. Okay? So this is our first example of how to find things. Now, what's a little interesting about this is I use equals. Is the name really equal to chef? It's not really equal to chef. Right? So we have to think about this mapping now equals mapping to the term query, which means find things with this word in it. And so let's go and grab our next example. Okay, got our next example. Okay, this is a new kind of filter. We haven't seen it before. It's called terms. Terms says, give me all the products whose name has chef or chai or sauerkraut in it. Okay, so if you're thinking about mapping it to SQL, this is like an ending clause in SQL. Now you can see we have 4 results. We have actually sauerkraut, and our 2 chef Anton strings, and chai. Okay? And how would you think that I would translate that into LINQ? Anybody? Contains, that's one way to do it. I'll do it like that. Okay, so let's say I have a list of things that I'm interested in looking for. Chai, or chef, or, what was it? Sauerkraut. Okay. So I could say, give me all the products where the names contain this product name. Okay, so I have a list of products I'm interested in. Is your product name in this product? Let's go ahead and run that, and we'll see we got our fallback. Right? And look, the query is exactly what I showed you. It's a terms query. That's a little complicated. What's another way I could have written that? Bunch of words, okay. Let's try that. So instead of this, let's say P name is chai. No, we'll do chai and chef. P name is chef. I think that he's turned that also into terms query. So he's taking the language that you're already used to using with your server, contains or anything like that. He's able to translate that into Elasticsearch query for you. Right? And questions like that. Alright, let's try turning into something. So here's a new filter. This is an AND filter. So if I was to write AND instead of OR, I could say, show me where I have something that has the name chef or chai or sauerkraut, and it's not a discontinued product. Right? So fairly simple, and collects these guys together. And I can see that of those 4 products that I used to get back, only 2 of them are not currently discontinued. The other 2 are discontinued. That's like they say true. The other 2, the sauerkraut and the gumbo mix, are discontinued. Alright, so this is a fairly straightforward translation of words. We're not going to put in the bottom of that. It's just and, right? We saw words. These are and. So. Okay. Let's find things where we have 10 of them in stock. Okay, so this is not a string anymore. This is now a number. So unlike with a string where things are broken apart on white space, numbers are not, they're not treated the same. Right? A number is just a number. So this is just some of the ones that have 10 in stock. Okay? So there's a couple of those. There's something I cannot pronounce, and Matsalaki. Those have 10 in stock. So this would once again be an equals, where P such that P dot units in stock is equal to 10. Okay? Interestingly with strings, but more interestingly with numbers, you can also do ranges. So show me where these things have between 10 and 15 in stock. Okay, so now when I do that, I get 9 inches stock. And this is, as you'd sort of expect, fairly straightforward to do. Units in stock. I'm going to make it again. Okay. So you can see that this translated it slightly differently than I did, but it's still a functional query, and we still get our 9 things back. 6, 9. Yep. Still get our 9 things back. Okay? So, as you can see, the few shots you already know, the data statements you already know in LINQ can help you query documents in Elasticsearch. Let's see. So, sorting is interesting, right? People like to sort data a lot, so sorting is one of the sort of last stage of the pipeline. So I can say, please sort this by units and stuff. So now what you'll see is that they're sorted in ascending order. Pretty exciting. Right? I mean, you'd expect it to be able to sort things, right? What you want to do is descending, and say descending. Now the 15s are on top. And once again, you would expect the LINQ things to work here. So let's say order by the units and stock. And now the query has a sort for units and stock on it. Okay? What else can we do? We can... Okay. This is our first query. This is what's called a query string query. So when I talked earlier about how people want to search for things, query string is generally the filter the query you're going to use to search for things. Query string basically says, this information came from a user. Try and figure out what they meant and find some things for me. Okay? So, here's a good example. I want to search the name for anything that starts with CH. So remember I said, there's chefs, I did CHE and I couldn't get anything back. Well, the nice thing is now I can get things that start with CH back. So there's our Chef Anton and some of the short trees right there. Lots of things. I start whittling it down. Now it's CHE. That just gets us our chef stuff. And of course, you don't have to have wildcards at the end. You can have wildcards in the middle if you like. So HE gets a lot of stuff with this, the HE out of this word here. Right. So this is what you would consider a traditional free text search. And it follows the rules of let's do chai. It follows the rules that users sort of expect. It's like, I want, chai or gumbo. How about that? So there's chai and there's gumbo. I want chai and gumbo, right? I'll send you a couple. I don't think people would like that drink very much. So, query string is typically what you're going to use. And users don't know that your database is in lowercase. So you can see here that I put a capital G on the gumbo, and it was just finding that. He figured it out. So query string is one of those very powerful things that you can sort of throw anything the user gives at it, and they'll probably get results back. And because it's a query, it has a score. So I've checked this box here, which hides most of the metadata, but let me uncheck it again for a minute. And for the first time, you're going to see things that have scores that aren't just 1. Because 1 is sort of the default score. And so the reason chai was first is he ended up with a score that was slightly higher, or a lot higher than gumbo. And for whatever reason in the logic probably says they put chai first before gumbo. So they probably care more about chai than gumbo. So that's why it's scored like that. Okay, so this is the Lucene engine. There's a lot of documentation on how the Lucene engine works. Scoring is obviously a very important part. The results you get back by default are ordered in score order. And if things have the same score, then it's sort of random in whatever order it wants to get it back to. So I can order by the score, even though it's ordering by the score by default. I could say sort. Let's get the worst ones first, right? So let's get for colon. I do that wrong. Sorry. We didn't do definitive. No, that's surprising. Anyway. So a query string. So how do I issue a query string in LINQ? Well, LINQ doesn't really have a query string on it. So one of the things we did when we did ElasticLINQ was we added some extensions to it. So one of the extensions is query string. If I issue that, this is going to send up the query string for chai or gumbo. And now that I don't know what the syntax is, let's find out what that syntax is for ordering it by order by score descending. I don't remember what the last syntax for that was. Or, oh, I think that's what I did. But he got Dumbo back first and I didn't. Yeah, that's the way it goes sometimes. Yeah, I'm not sure about that one. Anyway, so that's how you get a query string in the link. Okay? You can also use store as part of your filter. And one of the ways you can do this is you can say where elastic field. So elastic field is special fields for both the ID and the score. You can say only show me the thing that the score is greater than 1. Okay, so I don't want the bad results, I just want the good results. Now he took my score away entirely. That's kind of surprising too. I do say these demos work. Somebody accused me of failing all my demos, and it's kind of an accident. So there's query string hanging off of elastic fields. We can say, give me the things. I don't remember what the IDs for these guys were, so let's do this. Let's print out the ID, its name. So one is 1 and one is 5, so let's got a where clause on this. Say where ID is greater than 1. Oh. Right, so the string. So now he's only pulled back shift and complement. So you can use these special fields to further filter and sort your queries. So that ID value is different. So let me show you how I have laid out the documents in here. So one of the things that Elasticsearch has allows you to do is actually just browse your documents. So now if I was to browse the product document, you can see here that what I've done is the index is Northwind, the type is product to tell you it's product, and its ID is 28. Okay, so the URL for this is /Northwind/product/28. I've also put this ID field in here, which is an artificial construct of mine, which basically says, by the way, this guy is product 28. So anybody has a relationship to this, or you need to tell them how to get a relationship to this, you can tell them to use that. Right, and you can see that with this, for example, I have suppliers 12 and category 7 sitting here as relationships. Right, because suppliers and categories are a top-level element. So let's talk a bit about how we deal with these relationships. So let's say I want to find out who the suppliers of all my products are. Let's go ahead and look at all the products. And then let's go ahead and in a loop, we will write the product name and then the supplier for that product. So how many of the suppliers? Let's go query. So supplier, and we'll say where the supplier ID is the product supplier ID. Okay. So we're going to print the product name, and then we're going to print the supplier. And do no right here. Okay. So what product name am I using? What product comes from which supplier? So when I run this, you'll see that these are my products and these are suppliers. So I just did something horrible. What did I do? I did what's called an n+1 query. Okay? These are very dangerous in SQL servers. They're very dangerous in object databases. They're a little easier to do in object databases too. So what happens here is that I'm going through this product list, and for every product, I'm asking the database to go get that supplier for me. Right? So that means I had 9 products. I made 10 calls to the database, one to get all the products and one to get each one of those suppliers, including the fact that some of these are clearly duplicate. Right? New Orleans staging device is used in multiple places. So one way that I can deal with this, and this is something you would have to think about in SQL Server as well, one way that I can deal with this is I can turn this into 2 queries instead of 10 by saying, okay, I have all my products now. What are all the suppliers that I need to know about? Right? So, let's look at the supplier ID. And we will take, this is actually product. So the supplier ID is, let's go to the product list, and let's select out the supplier. Let's get a distinct list. That will give me the list of all the suppliers that I have. Okay, so let's just go ahead and actually print that list out. So that's the list of all the suppliers that I have that I need. Now that I have them in a list, right, we already know how to get them all in one call, right? Because we saw the use of contains earlier. So now I can get all the suppliers in one call. Now that's a list of all the suppliers. And I'm going to turn it into a dictionary to make it easy to look up based on that supplier ID. Okay? So make a dictionary based on the supplier ID. So now instead of using a query inside here, to get the supplier, I can say go to the suppliers and look it up based on the product supplier. And give me a name. So now what I've done is I've made 2 queries of the database. Let's go ahead and run this now. So we get the exact same list, but I've made now 2 calls of the database instead of 10. Right. So remember when I told you that relationships are a little more complicated than object databases, this is one of those things that are a little more complicated. Because in SQL I just use a join to go pull that information together and get it in one call. I had to get it in 2 calls, but at least I'm getting it in 2 calls instead of 10. Like, this is one of the things you have to think about when you're designing your queries, and you have these relationships that need to be followed. Right? So what other kinds of things can we do with it? Let's grab the next one of these. And put it in. Okay, so there's a function here called organic derived pairs. But I can't find it. And why is that? Now remember what we said about term querying, term filters, is that they look for a single word, right? They don't look for many words. So by putting spaces in here, he's looking for one word, which is organic space derived space pairs, which we don't have one word, because when we put everything in there, we told it to pull everything apart by spaces. Right? So I can go find that pairs product, by just looking for pairs, or looking for organic. So, in that scenario, what I can use now is what's called a match phrase. So I could use a query string, but query string is usually the most expensive thing that Elasticsearch can do. And, in fact, I could do this as a query string and show you, because remember, it shows me how long things are taking, like just 10 milliseconds. Query string is very expensive. So what I have here is I have the notion that I want to look for, strings of things together. So I can now ask for a match phrase for organic derived pairs and find the Uncle Bob's organic derived pairs, even though it has spaces in it. Right? If this is words that are connected together, though, so if I just ask for organic pairs, I'm not going to find it. Right. I could go back to my query string, which I think was this one. No, sorry, query string. Okay, I could go back to a query string, and I could say find organic pairs. And of course, he's going to find that, because remember, a query string is, the most powerful thing, but it's also the slowest. So, match phrase is another thing for you to consider when you're looking for more detailed matches, but the words might be broken apart on you, a match phrase can ignore the fact that the words are broken apart and find them all together still. Okay, where this becomes really interesting is when you're looking for things based on an identifier. Maybe the identifier is broken into pieces. Maybe your identifiers have spaces in them. Right? You could use a match phrase to help find that identifier. But what we do is we make sure that our identifiers don't fall afoul of our word breaking. So for us, our identifiers typically are GUID. Right? So, big 32-character number, letter, nonsense, unique identifiers. So we can easily look up by them, and they won't be broken apart into spaces, because they're literally just 32 characters in each. So think about match phrase in some of these scenarios where you know the words are broken apart, but you still need to find them together, but you don't want to pay the cost of equation. Okay, I think this is the same one. Okay, so match phrase. So let's go back to this one. So I talked about how he's limiting results to 10 at a time. Let's tell him to limit to just one result. So that's the size keyword. So now I get one of the 4 results. What happens when I want the next one? So when I want to page through the results, I want to look at them one at a time, but I want to look at the next one. So I want to say so chai was, 012, chai was the 3rd item on the list. Okay, so from and size are the things that you can use to page through these results. And of course, LINQ has half of their things for this, right? Take and skip. So when you use take and skip and LINQ, you're getting exactly this. So let's go here and let's say I want 2 products, but I want you to skip one of them. Oops, I need to do this up. Let me extract this into a query again. So we can see the query he's giving us with from inside. Okay? So give me the 2 products starting with number 2. Basically what this is. Picking one. Okay? And let's see, I think one more. And over again. So, when I talked about the pipeline, the one thing we haven't talked about in this pipeline, right? We've talked about query and store, we've talked about filter, we've talked about paging. The one thing I haven't really talked about in this pipeline is Facets. So remember when I said you have very limited sort of statistical reporting out of these things? Facets in Elasticsearch are its way of giving you some statistical report. Okay? So what I'm going to do is I'm going to run this query which says, give me a facet called discontinued products, and in order to figure out how many things I would like counted in that list, give me the ones based on this filter. So show me the ones that are discontinued. Okay? And I'm going to do size 0, and I'm going to talk about this in just a second. I'm going to uncheck this box. If I run this, it says 0 results. That's okay, because I told him to give me 0 results. But if I look down here at the bottom, I will see that there's a facet that was included in the results set, which says, by the way, I found 8 discontinued products for you. Okay? And this is, this is one of those things that, it's very useful for being able to count. So the version of ElasticLINQ I'm using today, I would show you how to do this. Unfortunately, it's coming in the next version, which hopefully will just be a couple of weeks away. But you'll be able to use things like count and group by, right? All these things turn into facets in Elasticsearch. So what would group by look like? Let's call this product by supplier. Okay? And now we're not going to use a filter anymore. This time we're going to use a terms. And what we say is, because we're already searching products, the field now we want you to count the group things by is supplier. So now when I run this, he will tell me what are all the suppliers and how many products do they have. Okay, so these are some fairly basic things on top of which you could build some fairly advanced reports. Okay, so this is sort of the basic reporting functionality of Elasticsearch. Okay, so why do I say size 0? Remember what my pipeline is. Okay, my pipeline is a query, a filter, facets, and then pages. So I have not told him to limit when he comes back. So if I do this without size, he's going to give me the first 10 results of my query and filter, which I don't have a query, I don't have a filter, which means all the documents. By the way, here's the first 10 documents. And then I scroll all the way to the bottom, and when I get all the way to the bottom, I see my passage. Usually when you're counting things, you're not interested in the documents, you're only interested in the counts. That's not always true, though. Sometimes you do want the document. So if you think about just counting things, I would just want to count them. But if I want to group things, I want to use this to help me group things up. I can do that and still get all the documents back at the same time. Okay, so that's some of the power of Elasticsearch. All right, any questions? No. Okay. So why ElasticLINQ? I think, the last 45 minutes have sort of addressed why ElasticLINQ. But it gives you the power of Elasticsearch and the power of an object database. You get to keep all of your C# classes or your VB classes. You get to write the queries that you're already used to writing with NoSQL and anything, except you get to use now a nice distributed NoSQL document store. Right? Fairly pain-free way to get started with Elasticsearch. It doesn't cover it 100%, but it covers it about, 70 or 80% right now. It's not the first project. So one of the things that, you could be done is you can contribute. Something is missing, feel free to send a pull request. Feel free to submit a feature request. We have several of those right now. The Facets for counting stuff was the first one that we're going to integrate as the next feature request. So why Couchbase? So I started this talking about how we chose to use Couchbase. And we arrived with Couchbase pretty much for the sole reason of its cross-data center replication. Right? Couchbase is a database that is capable of massive scale. How many people run a SQL server that has billions of rows in it? None. Not even, well, I shouldn't put my hand up. I don't do that. But I could. I run a Couchbase server that could run billions of documents. I don't even know what it would take to run billions of tables, billions of rows in a SQL server. I have no idea what the hardware requirement of that is. I have a pretty good idea what it is in Couchbase. So when you have things that need a lot of scale, so you think about, I don't know, maybe you work for a cloud company. I don't know, maybe you have 11 data centers, and you want people to be able to log in from all over the world. Right? This is one of those things that this is really good at. In the past, we used SQL Server, and we replicated that data ourselves, because we went down and the SQL replication path inside of Microsoft SQL Server, and we couldn't really make it work. So we ended up having to handle our own code, and it was creeping at the seams. So we chose Couchbase for this exact reason. And obviously, Couchbase led us to Elasticsearch. Just like Elasticsearch, it has both open source and commercial options available. So why use Couchbase with Elasticsearch? Couchbase with Elasticsearch, you can put your documents in Couchbase and they will automatically show up in Elasticsearch. This gives you the benefit of being able to store and retrieve documents from Couchbase. You can also retrieve them from Elasticsearch if you wish. You can also use Elasticsearch to full text search the documents that you put into Couchbase. Couchbase doesn't really have a search algorithm. It doesn't really have a search system at all. It allows you to get a document from an ID, documents from a range of IDs. I think that's it. That's what it does. Yeah. Sure. So the question is, what if I wanted to say search a bunch of emails? So Elasticsearch is what's going to let you search those emails. So the question is, do you use Elasticsearch by itself, or do you use Couchbase and Elasticsearch? Because Couchbase doesn't really give you the ability to sort of search for things from the shell. But you can see from what we showed of Elasticsearch that it's clearly capable of doing that. So the answer to that question would be, do you have a need for having that data in multiple locations around the world at the same time? Right. So that's why I would choose Couchbase. If I just need to have the data in one location, I would just choose Elasticsearch by itself. So for us, we have 11 data centers around the world, US, Canada, Germany, the UK. We want that data everywhere so that people can have access to it in tens of milliseconds instead of single digits of seconds. Right, so that's one of the things that Couchbase did for us. Question about that? No. Couchbase is a separate product. So I'm going to show you guys Couchbase in just a moment. So pluses and minuses to Couchbase and Elasticsearch, right? Couchbase is just storage. And its plugin support is limited. But plugin support in Elasticsearch is much better. And of course, Elasticsearch is a full text index. That's why I actually think these two technologies are very complementary. We haven't really talked about schema much. Elasticsearch, you didn't see me talk about schema. Elasticsearch sort of infers schema. When you put a JSON document into it, it says, there's a number here, there's a string here that looks like a date, I'll call it a date. One of the interesting problems with that is, the first time I put a document in to Elasticsearch, and I use ID, and it's a number, right? And I try to put another document in there, and he also has a field called ID, but he uses a string. Right? The first time you send a string in there that doesn't look like a number, Elasticsearch is going to go, whoa, this doesn't match what I thought the data was supposed to look like, so I'm not going to index that document. Okay, so the schema in Elasticsearch is dynamic, but once it's there, it's kind of set in stone. So you sort of need strategies for how you're going to deal with that in Elasticsearch. And one of the strategies you can use in Elasticsearch, which I was using over here, is you can actually give the documents different types. So you can see down here I have categories. Right, so these are the categories. These are the companies. And so I've used a type discriminator in Elasticsearch. Now, unfortunately, when you use Couchbase with Elasticsearch, all the documents show up as the same type. So they all have the same schema. Okay? So the way to work around this is you make sure that that when you have ID, for example, it's always a string. Okay? And then you use a type field to say, this is how I discriminate which documents are of which type. So in this example, we have a beer type and a brewery type. They have different values in the documents. The documents are structured different. But they both have type of a string, they both have name of a string. So if you're willing to live within those confines, then you can use this system where you just sort of make sure to do that. Personally, I find that to be pretty restrictive. I accidentally put a document in with an ID with a number first, and then if an ID are numbers forever, that's pretty tough. That's tough love. Okay? So a different strategy you can use is you can use what's called a type wrapper. And because JSON objects can be of arbitrary depth, what you basically do is anytime you put a document into Couchbase, you put it in with a single property, which is the type of the document. So in this case, it's beer or brewery. And then the object that is pointed to by that property is the beer or the brewery object. And so now, beer.name has a different schema from brewery.name, and they don't have to match. So this is a strategy we use when we use Couchbase and Elasticsearch to prevent these collisions. It's unfortunate that that's the way the Couchbase team decided to write that, but Couchbase really has no notion of document type, so you can't really fault them for it. It literally just has documents. Elasticsearch has types and puts schemas around those types, so in order to marry these two worlds together, this is one of the strategies you have to take. Okay, so let's talk a little bit about Couchbase. This is the Couchbase console. Just like Elasticsearch running two machines in a cluster, I have two machines in this Couchbase cluster. Alright, so I can look at these two server nodes, and they'll show me RAM usage, swap usage, CPU usage, very important things. I have one data bucket in here. It is the beer sample. This is actually one of the built-in samples from Couchbase. If you go over to settings and then go over to sample buckets, I think he's upset about not being on the internet. But for our sample bucket here, the beer sample is one of those buckets. So I have this beer sample bucket, and I can go look at some of these documents. And you can see that what they've done is they have taken this strategy, the first strategy that I mentioned, which is to use a type field to differentiate between them. So now that I have documents in Couchbase, which you can use, they have an API of their own, they have an API for .NET, and pretty much every other language imaginable. Node, PHP, Java, Erlang, Go, all kinds of good things. So you can use their API to get and retrieve documents. So now once I have documents in here, what I do is I use the cross-data center replication feature. And why does he not think that there are any of these? It ought to be. That's unusual. Okay, so I have set up a remote cluster to my Elasticsearch node. So one of the other plugins that I put inside of Elasticsearch is a plugin called Couchbase-Elasticsearch, and he basically makes Elasticsearch look like a Couchbase server. So a Couchbase can then push documents out in, just like he was a data center halfway across the world, except he's one virtual machine over. So anytime we put a document in here, he shows up over there. So let me go ahead and we can go look at this. So if I were to look at the view sample of documents, you can see all of their types are Couchbase documents. Right? All of those documents are over here. And let's see, let's sort by ID, and let me go add a new document into this guy. Create a document, and hey, there's a document called AAA. And then I come over here, and I say refresh, and we have an extra document. So let's go get that document out. Alright, so this is going to be view sample, Couchbase document, and okay, there's my document. And then if I look at source, that's the document I just put in Couchbase, and you can see it immediately shows up over here in Elasticsearch and is now available for me to find. Right? I were to go into Couchbase and now delete this document and try to do this again, you would yell at me that that document doesn't exist. Right? So you can see how fast that is. It's very fast. Put a document in Couchbase, very tiny numbers of milliseconds later, it shows up in Elasticsearch immediately. Right, that's how you compare Couchbase and Elasticsearch together. Couchbase is a fantastic piece of software. This is the open source version. It's called the Community Edition. Community Edition is usually behind the commercial edition by one release, or maybe a couple. But what's nice about it is it does things like you can see he keeps fairly good statistical models of what's going on. So the administrative tools for Couchbase are very nice. This is 5 minutes, so we do hour and day. I guess hour is going to be good because I haven't really done much for this guy. But so you can see that what happened here in this last hour is, we had some operations. You can even see, how many outbound operations that I have to send to Elasticsearch. You can see here where he replicated the document out there, and then he replicated the delete out there. So some very nice administrative tools for Couchbase. This is a very nice document store. But really, that's all it is a document store. A very powerful document store that can sling your documents all the way across the internet, which is how we use it. Alright, so let me do something incredibly dangerous. And let me see if this is even possible. Oh, yay! Long questions! One moment, please. This is always fun. What happens when you change your password 3 days before a demo? Copy my password. Yes, please. Come on. Somebody's upset. Copy. Come on. Oh, who did I get connected to? Washington. Okay, that's good enough. Alright, Couchbase. I can get this staff meeting dialog after this. That would be fantastic. You're killing me, Viscosity. That's awesome. That's even more awesome. Oh, sad panda. Oh, I came back. Okay, cancel. Sorry about this, guys. You are killing me with this, Captain. Well, I wanted to show you guys. Probably not still connected. Oh, I am still connected. Hi there. So this is our Couchbase cluster in Washington. Actually, let me go to one in California. So this is our Couchbase cluster in California. This is one of the ones we just built up. And you can see, running 6,000 operations per second at some point. Right? This is just running on fairly standard virtual machines inside of our own cloud. We have many data buckets. We have a main data bucket with 3.5 million documents that's replicated all the way around the world. And then we have some buckets that are basically local buckets with less documents in them. So you can see here in this cross data center replication, when I see this guy is replicating to his own Elasticsearch locally, but he's also replicating to Great Britain and Virginia. Okay, so we have them spun up in a ring, and they send documents out both directions around the ring, so they can get around the world, as well as to a local box that's sitting very close by running Elasticsearch. Right, so you can see we put everything in Elasticsearch, pretty much, because we want to be able to search everything, but then we also send this main bucket out to Virginia and Great Britain. This is a setup we've been using for more than a year now, and it's been incredibly powerful and stable and wonderful for us. It's been a very good investment. Okay. I know I went through the Couchbase stuff fairly quickly. That's primarily because I just want to give you a little bit of an overview about why we choose Couchbase, why Couchbase sent us to Elasticsearch, things that you may want to look at. If you have the kinds of problems we do, some people do, most people don't. Use Elasticsearch by itself if you don't. If you have big data around the world problems, you should consider Couchbase for that. Any questions on Couchbase? No questions on Couchbase? Okay. So, what's next? Go home and look at this stuff. It's all on the internet. It's all fairly easy to find. Like I said, I'm going to post the slides that'll have all the links in them. The only link I have to remember is the link to my blog, which I'll give you here in just a moment. And Jim mentioned the free CenturyLink Cloud demo. If you don't have virtual machines that you want to do this locally, or you don't have powerful enough hardware, you just want to see what it's like to run this stuff up to the cloud. You want to try our new hyperscale stuff, which is blazingly fast and probably faster than every Denver box you've ever worked on. Sure, try our stuff out for 30 days. It's a good place to try this stuff out. That's my job. Try ElasticLINQ on your data sets. Put some of your data, figure out where those domains are. Play around with putting your data in Elasticsearch. Play around with some of those queries. Play around with ElasticLINQ and see what it's like to pull your data out of there. I used to work for Microsoft, so I wish them all the best, but I don't want paying them $10,000 for a license for SQL Server. There's a lot of free stuff out there. So this is your opportunity to go learn something free that maybe you wouldn't have known before. And of course, contribute. You get to the point where you're using Elasticsearch every day. That's awesome. Contribute. We love feedback. We love bugs. We love feature requests. We love documentation, which we have hardly any of right now. That's one of, remember I told you most open source projects have terrible documentation? This one does too. So, that's a good place where you can contribute. It's brand new. We announced it 6-8 weeks ago probably. So it's still a very new project for us. But we've been using ElasticLINQ inside of our product for months now. Right. So we know it's stable for what we like it to be used for. When you go to our website and you look at our stuff, this is pretty much a lot of the stuff you're doing is powered by this. Okay? So that is your link to remember, bit.ly/BradTalk. That's Brad's Talk, not Brad's Talk.